let's talk about something you might be familiar with already, sequences. Let's say we have the sequence ace of n is equal to ace of o times, let's see, we'll say times r to the power of n. And we'll say that ace of o is 1, and we'll say r is 0.5. So let's substitute our values. We have ace of n is equal to 1 times that, so we don't have to write the 1. So it's 0.5 to the power of n. And we can just say that n, we'll say n starts at 0 and, goes to whatever you'd like. So what does this mean? Well, this is a sequence, and the term in the sequence is determined by this formula. So the 0th term in the sequence would be ace of 0, and that would be 0.5 to the 0, and this is just 1. So the first term, I'm going to write the sequence here, is 1. The second term, or the first term, sorry, this is the 0th term. So the first term in the sequence is ace of 1, which is 0.5 to the 1, and that's just 0.5. So this right here is the first term in the sequence. Again, this is the 0th term. This is the first term. Usually the 0th term is, usually we start with quote unquote the first term, but it doesn't really matter. We can say this is the 0th term and this is its first term. Now let's find the second term. So the second term, well, that would be ace of 2. This is equal to 0.5 to the second, and this is equal to half of half. Well, that's 0.25. So the second term is 0.25, and we can keep going, right? We can keep going. Now let's say we want to find the infinite sum. So I'm going to write it like this: the infinite sum from n equals 0. Sorry, this is n equals 0, and this is the summation symbol, right? This means the infinite sum from 0, we'll say to infinity of this same sequence that we have of ace of n, right? Well, this is just equal to, the infinite sum from n equals 0 to infinity of 0.5 to the power of n, right? So what this means is we're going to start adding up all the terms from 0 to infinity. So we have a few of them already, so let's add those, and let's just see how it behaves. So the first, or again, the 0th term we have is 1. So this is going to be 1. And obviously we can do this manually, so I'll show you a way we can do this. And you might already remember this from probably geometry or algebra 2. But let's do this by hand first. So the 0th term is 1. The first term is at 0.5. The second term is 0.25. Let's do one more. The third term would be ace of 3, which is 0.5 to the third. Which is equal to half of 0.25, right? And that should be 0.12, let's see, 0.125, I believe. There we go. So 0.125. And now the next few terms, they're going to just keep getting smaller and smaller, right? So if we add these few, we should get a good estimate of what our sum is. So let's do that. So 1 plus 0.5, that's 1.5, plus 0.25, that's 1.75. So it's 1.75 plus 0.125. So we'll write a little squiggly equal sign. That means it's sort of equal to this. It's not exactly, right? And that's equal to 1 point, let's see, 875, I believe. So this sum should be somewhere around 1.875, probably a little more, right? Because we're going to keep adding terms that are smaller, but nevertheless they're terms, right? Now, a way we can actually accurately find this, you might remember this formula from geometry. If we have some sequence where it's defined by ace of 0 times r to the power of n, this is just the formula for the infinite sum would just be, so I'll say the infinite sum from n equals 0 to infinity would just be the first term, ace of 0, over 1 minus the rate. This formula gives us the infinite sum of this sequence. So let's figure it out. Well, we know that the 0th term is just 1. So 1 over 1 minus, well, the rate, or the r, is 0.5, right? So 1 minus 0.5 This gives us 1 over 1 minus 0.5 is a 0.5. And 1 divided by 0.5, this is just 2. So the infinite sum of that sequence from 0 to infinity is 2. And that makes sense, right? Because we did it by hand, and we noticed it's around, it's 1.9 or so. It should be a little more because we didn't add some terms, right? We actually didn't add an infinite amount of terms because we can't do it by hand. But we added the major ones, and we noticed that it should be around 2. And we did it with the formula, and we noticed that it is indeed around 2. And this right here is I want to introduce the idea of converging. And the term, or the infinite sum of the sequence, converged to a certain value, which was 2. And so I wanted to introduce sequences here. If you forgot about sequences and you forgot about this formula, this is an introduction to sequences and also an introduction to the infinite sum of sequences. And in the next video, we will talk about convergence more in detail.